Example 2. In this video, we will graph the solution set to y is greater than or equal to x squared minus 3x minus 4. We're going to use the same concepts that we used for example 1, but this time our graph is not a line. This time our graph is a parabola. Now, I believe that Alex focuses on completing the square and graphing that parabola using transformations, but I'm going to find the vertex and the x and y intercepts. So remember, to find the vertex of a parabola, what you're going to do is use the formulas. The x coordinate is negative b over 2a, and the y coordinate is f of negative b over 2a. So in this case, a is equal to 1, b is equal to negative 3, and c is equal to negative 4. Sorry, that's kind of bleeding in there. So that's going to give me x is equal to negative b, which is negative 3, over 2 times a, which is 1. Well, the opposite of negative 3 is 3, and 2 times 1 is 2. So the x-coordinate is 3/2, or 1 1/2. The y-coordinate is going to be f of 3/2. So if I plug that in, I'm going to get 3/2 squared minus 3 times 3/2 minus 4. Well, 3/2 squared is 9/4. 3 times 3/2 is, 9/2 minus 4. And just for time's sake, well, I went ahead and found a common denominator. So that would be 9/4 minus 18/4, because 2 times 2 is 9. So I'm sorry, 2 times 2 is 4, and 9 times 2 is 18. And then to put this over fourths, it would be 16/4, because 1 times 4 is 4, so we do 16 times 4. Now you can also enter this in your calculator, and it will do the common denominator work for you. But 9 minus 18 minus 16 gives you negative 25/4, which, if we change to a mixed number, is negative 6 1/4. So we know the vertex of the parabola. It is 1 1/2, comma, negative 6 1/4. So what I'm doing is gathering information so I can graph the parabola. And remember, the parabola serves as a boundary for the shaded region of the graph. So now, to find some more information, I can find the x and y intercepts. So to find the x-intercept, remember, you let y equal 0. So that's going to be x squared minus 3x minus 4. And I'm going to set that equal to 0. This is factorable, so x minus 4 times x plus 1 is equal to 0. Negative 4x plus x will give me the negative 3x, and negative 4 times 1 would give me the negative 4. So my two x-intercepts are x equals 4 and x equals negative 1. And I got those by setting each one of those equal to 0. So I guess I could do the preliminary step here. X minus 4 equals 0. And if you add 4 to both sides, that gives you x equals 4. And x plus 1 equals 0. And if I subtract 1 from both sides, that gives me x equals negative 1. So there's 2 more points on my parabola, 4, 0 and negative 1, 0. Finally, I can find the y-intercept, which will give me the fourth point, and I can reflect that to get the fifth. To find the y-intercept, we're going to let x equal 0. So that means we're going to plug 0 into our function. So we'd have 0 squared minus 3 times 0 minus 4, which will give me negative 4. So 0, negative 4 is another point on this parabola. So I'm going to go to the graph, and I'm going to start graphing the information I've collected. So 1 1/2, 2, 3, 4, 5, 6 1/4 is somewhere in here. And then I have 4 0, 2, 3, 4, and negative 1 0. And I'm sorry, this one is not 1 1/2, negative 6 1/4, which would be right here. And then finally I have 0, negative 4, 2, 3, 4, and I can reflect that here. What is not matching up here? I guess it is. It just looks funny. I'll make it bigger. Yeah. Now, I need to decide, should I be graphing this with a dashed line or a solid line? Again, in this example, we have the equals to, so that means we're going to graph it with a solid line. Gosh, I'm running out of room. All right, so give me a minute here. I'm going to draw this parabola best I can. Now, what this parabola does is to divide the coordinate plane into a region that works, or a region that contains points that satisfy this inequality, and a region that contains points that doesn't satisfy the inequality. So the region is either going to be inside the parabola or outside the parabola. One of the ways you can do that is to choose a test point like we did up front. We just kind of did it before we drew the graph. And if the origin is in one of those regions and not on the boundary line, that's what I pick. So I'm going to choose 0, 0. What I'm going to do with that is I'm going to take that ordered pair, I'm going to plug it in my given inequality to see if it gives me a true or a false statement. So that's going to give me 0 is greater than or equal to 0 squared minus 3 times 0 minus 4. 0 is greater than or equal to, that's going to go away, that's going to go away, and it's negative 4. That is a true statement. So what that means is that 0, 0 worked, and it lies inside this parabola. So if 0, 0 works, all the points that are located inside this parabola will also work. So this shaded region is the solution. Now, you could always test to make sure that you got the right shaded region. You could either pick another point in here, or you could pick a point outside. What do you think would happen if you plug in a point outside? Well, let's see. Let's do an additional test point. Let's pick the point here That is -2, 0. And again, I'm going to plug it into my original inequality. So I have 0 is greater than or equal to -2 squared minus 3 times -2 minus 4. So I'm plugging it into that original inequality. That's going to give me 0 is greater than or equal to 4 plus 6, -3 times -2, minus 4. So that's going to be 0 is greater than or equal to 6. Well, that is false. And that's what we would expect to happen if we pick a point that does not lie in the shaded region. So that's just more confirmation that we worked the problem correctly. So just to kind of reiterate, to graph a single inequality in two variables, you're going to plot the graph that goes with the equation. And I'm sorry, I did kind of skip that step. So what I was doing here was graphing the equation y equals x squared minus 3x minus 4. And for a parabola, you could either use transformations if you put it in vertex form, or you can just find the vertex and the x and y intercepts, which is what I did here, so that I could make an accurate graph of the parabola. And then you pick a test point to see which of the regions work, either inside or outside the parabola. Now, there is one other thing I want to point out here. Notice that in this case, we had a greater than or equal to, and y was by itself on one side. When y is by itself on one side, you can just use the inequality because this region would be considered above the parabola, whereas the outside would be considered below. You can't use that reasoning, though, here because y is not by itself on the left. So when you don't have y by itself on the left, you're left to be required to use a test point to see which region works. Because had I used the less than or equal to, I would have shaded below the line, but that is not the correct region. In the next videos, we'll graph a system of inequalities. So what happens when you put two things together?